So histogram processing. So here, what is the histogram and what is the histogram processing, and how can you get the histogram equalization and also histogram matching or specifications. These are the important topics. So here, histogram is nothing but, its general definition is, it is a plot of frequency of occurrence of an event, right? So that means here this is nothing but a graphical representation, right? So graphical representation in between the generally frequency of occurrence and events. That means we have so many events, right? So here, if you observe, at what times, right? So how many times here that event will be occurred, right? That is the here intention. So here, if you see this graph here, so many events are there. So consider like 0, 1, 2, 3 events. So here, if you observe 0th event, so there is no bar graph or line here, right? So here consider like this, okay, 0. That means 0th event is not occurring, right? So that means here, what is the frequency of occurrence here? 0. Consider like that, just an example. Now coming to this one, the event 1. So event 1, so what is the frequency of occurrence? Let it be here, suppose it is a F1 or some O1 like that. So here O1 times this event 1 is occurred like that. So event 2 is occurred. So here in this level, right? So that is the consider O2 like that. So this one is the O3 like that. So event 3 also, that one also occur in the O3 times like that. So that means here, if so many events are there, how here each event so will be occurred how many times, right? So we should calculate and then we should draw that one, or we should give the pictorial information to the particular users, right? That is the intention here. So histogram is nothing but it's a graphical representation, so which gives the information. So that is nothing but so frequency of occurrence of an event. It's a general definition. So coming to the technical definition here, so if you observe if you consider the what is that image, right? So if you consider the image, right? If you consider the image, so here image has particular size, m by n size, and then we have the so many gray levels here. L gray levels are there. So what is the range of particular pixel intensity in that particular image? 0 to L minus 1. Of course, you know all these things, right? So here, how can you evaluate? How can you draw the particular one with respect to what is that histogram, right? So how can you calculate the histogram? That means how can you draw the histogram for the particular image, right? So here coming to the definition for the histogram. So here in this digital image processing, so consider one image and we have the 0 to L minus 1 intensity levels. So here this histogram is a discrete function. So that is the h of rk is equal to nk. H of rk is equal to nk. So here what is nk and what is rk here? So here rk is nothing but, so here intensity levels, right? Intensity levels. So here I am taking some suffix k value. Rk is nothing but kth intensity level. So here how many intensity levels are there? 0 to L minus 1 intensity levels are there. So that means here rk means R0 to RL minus 1. We can represent like that. 0th intensity is nothing but R0. So first intensity is nothing but R1. So second intensity is nothing but R2. 50th intensity is nothing but R50. 100 intensity is nothing but R50. We can represent, we can indicate the particular intensity values with respect to symbols like this, okay? RK, okay? So consider like that. So here RK is nothing but R0 to RL minus 1. So observe here NK. What is the NK here? How many number of pixels are there with the intensity level RK? So how many pixels are there with the intensity level RK? That means here if you observe the whole image, we have so many intensity levels in that. So from 0 to L minus 1. So in total image, how many pixels are there with the intensity 0. We should calculate. We should separate, right? And then how many pixels are there with the intensity value 1? How many pixels are there with the intensity level 2? And so on. Like that, we should calculate all these things, and then those are represented like in a nk. So that means nk means here n0 to nl minus 1 values are there. That means n0 means here, what is the meaning here? The total number of pixels with the intensity r0, that is nothing but 0. Okay, right. So understand this one. Okay, so now here h of rk is equal to nk. So what is the here h of rk? Histogram of the function rk. So that is nothing but nk. Both same, right? So now here, what is the here graphical representation here? So that means here we should draw the graph in between the two what is that axis? On x-axis you just consider the rk value, on y-axis you just consider the nk value or h of rk value. Now you should draw the graph between h of rk versus rk, otherwise you may take like this nk versus rk. So kindly note this point. Okay, very important. What is that? nk versus rk, otherwise h of rk versus rk. Okay, right, it's okay. Now here this is one of the what is that, what do you say, representation here to draw the what is that, represent the histogram. Okay, so to draw the histogram, so here h of rk is equal to nk means, so observe here what is that? Suppose if I take the dark image or bright image, that means if I take the dark image means in that image only 0th intensities are there. M by n size is there, right? So consider like 100 by 100 like that. So 100 by 100 size of an image is there. So here fully I am taking the, what is that, dark pixels. That means here, tell me, here, if you draw the graph for this image, or if you establish one histogram for this type of image, x-axis is belonging to the different intensity levels. So here that image also 8-bit image. So what is that? 8-bit image. So if it is 8-bit image, so here how many gray levels are there? 256 gray levels are there. Starting value 0, ending value 255. Am I correct? 0 to 255. So 0 to 255, we should indicate all these levels on x-axis. 0, 1, 2, 3 and so on 256. So now you should, what is that? Draw the discrete lines at this each and every in level. Okay, right? So what is the here? How can you draw these discrete lines here? So here we should count. We should count how many 0th intensity pixels are there. Right? So you should count. So what I said earlier here, I just consider one image which is having the almost all are equal to 0. Dark image is 0. So 0 means here 0. So here that means here how many pixels are with the 0 intensity? In the image size is 100 by 100. That means 10 power 4. 10 power 4 pixels are with the intensity 0. So on x and y axis, take 10 power 4. Okay. So on at x is equal to 0th intensity. That means on x axis, just take rk. That means r0 is nothing but here at 0. At R0, just to take the value 10 power 4, right? We should indicate that one on y-axis. So, okay, here, So how many pixels are there with the 1 intensity? No, 0. How many pixels are there with the 2? There, no, 0. So in such a way, other than the this 0th intensity, remaining all the intensities are having the, what is that, h of rk or nk value 0. So just indicate 0 like that. So in such a way, you should draw like, okay, right. So now here, what is the difficulty here? So here on y-axis, so what is the minimum? What is the minimum value and what is the maximum value? Right. So minimum is the, of course, 0. What is the maximum value? So you may expect like that. So here, the image size is m into n, right? So we may expect m into n value on y-axis. Am I correct? That is as a maximum value. So maximum value on y-axis is nothing but image size. Okay, right? Number of elements in the image. That is nothing but m into n. So for the large image, right? So here for the large image, this number is very high. So we cannot draw that one on. We cannot. What is that? It gives certain, what is that, a very large gap, right? So large gap between the lower value and the higher value, right? So very difficulty to indicate those values on y-axis. Okay, so right, that's why here we should normalize these y-axis values, right? So okay, so to do this here, we just use the normalized histogram. By using the formula P of Rk is equal to Nk by Mn. We are normalizing the values. That's why here the maximum value is the Mn. So here divide the each value with the Mn value to get the upper value as 1. Okay. So that's why here. So here what is the general formula? H of Rk is equal to Nk. But now P of Rk is equal to Nk by Mn. Nk by Mn. So that's why here we can get the, what is that, range of y-axis or range of histogram values in between 0 to 1 only. Okay. So okay, now here P of Rk is equal to Nk by Mn. So M and N are the row and column dimensions of the image, and P of Rk is an estimate of the probability of occurrence of intensity level Rk in an image, right? So remember these two formulas to draw, to represent the histogram. The first one is H of Rk is equal to Nk. The second one is P of Rk is equal to Nk by Mn. Okay, so here also you just draw the histogram in between the P of Rk versus Rk, otherwise Nk by Mn versus Rk, right? Now see this. Any doubts here? Any doubts? Now see here. So here what is the use of this type of graph, right? So you can easily understand the what is that image information. That means here how many, right, pixels are there with the, right? So low intensity levels. How many pixels are there with the high intensity values? So in that means here, based on this graph, you can easily identify the, right? So what is that? Which intensity values are having, which intensity levels are here with the, what is that, large number, right? So any unnai anedi manam easily identify cheyochu. You can apply the threshold value also based on that one. Okay, right? So here That's why here histogram of images provide a global description of their appearance, and enormous information is obtained. It is a spatial domain technique. Of course, histogram of an image represents relative frequency of occurrence of various gray levels, and histogram can be plotted in two ways. The first one is nothing but based on the formula H of Rk versus Rk, otherwise Nk versus Rk. So here take gray levels on x-axis and number of pixels in each gray level on y-axis. Okay, so now here if I give one image, right, first after seeing that image, after getting some what is that each pixel intensity information from that image, you should establish one table first of all. So, okay, we should establish one table like this, right? So here we directly take that table, right? So here, but you should know that how can you draw this table from the graph, from the image. From the image, right? So, okay, firstly, this table consists of two columns. One is the gray level, and other one is the number of pixels like Rk and Nk or H of Rk, right? So that's why here, firstly, we should concentrate on gray levels in the image. If it is a 8-bit image, it has the 0 to 255 levels, right? So total 256 levels, 0 to 255. So you should write like that, 0, 1, 2, 3, 4, and up to 255, like that. So if it is a 2-bit image, so okay, here 4 levels are there. So like 0, 1, 2, 3, like that. Okay, so like that here, firstly, so you should concentrate on the how many gray levels are there in the image, and then you should include all these levels in the first column. And then next one is the number of pixels, and then here you should find out from that image how many pixels are there with the 0, right? So just we just write one simple algorithm. So according to that, so that loop continuously counts the intensity value. Okay, so then we can get that one easily. So okay, that means here in the image you should calculate how many pixels are there with the 0th intensity. So in the same way, how many pixels are there with the 1 intensity? So like that you should count, right? So here after completing this task, right, the second column is nothing but, see that, so for the given image 40 pixels are there with the 0 level, 20 pixels are there with the 1 intensity level, and so on, like 3 pixels are there with the 5 intensity, and 2 pixels are there with the 6 intensity. Okay, here 6 intensity levels are there. Okay, sorry, 7 intensity levels are there. Okay, so it's okay. So no need, actually we may consider like what is the 2 power n values, like that. That means we may consider like that is the 3-bit image. So we have the 8 gray levels. 8 gray levels means we should start with 0 and ends with the 7. Okay, we can take like that one also. So here and for if suppose if there are no pixels with the intensity 7, you just add 7 and then in the number of pixels you just give that information like a 0. Okay, so we may not we may include that one also. It's okay, right? So just an example. Now here, how can you draw the histogram? This is the histogram. Observe this one. This is nothing but histogram. So don't say like by seeing this graph like this. So we cannot say, oh, this is the graph. This is the what is that one sketch like that. So you should say the word, what is that, histogram, by seeing this one in the image processing. So this is the histogram for the given image. So in such a way we should call like this. Okay, so here take x-axis, take what is that Rk on x-axis and Nk on y-axis. So now here include the gray level 0, 1, 2, 3, 4, 5, 6, and then here mark here discrete lines. So discrete lines. So mark like 40 pixels are there with the 0. Now here 20 pixels are there with the 1, and here 10 pixels are there with the 2, and so on, like 2 pixels are there with the 6. Like that you just draw the discrete lines here. Okay, so this is nothing but, what is that? This is nothing but histogram. So by seeing this one, you can easily identify that here in that image, right? In that image, how many pixels are there totally. Okay, right? So what is the image size? So you can get that information also. And also here, among all the pixels, right? So how many pixels are there with the particular intensity? That means from this graph, we can easily identify that 0th intensity pixels are very high. See this, 40. Right? Among how many total pixels are there? What is the image size here? By seeing this, we can say, what is that image size? What is the image size here? Anyone in the class? What is the image size? You just add all the pixels here. 40 plus 20 plus 10 plus 15 plus 10 plus 3 plus 2. That gives here, what is that? Total number of pixels in the image. Okay. So here if you add, right? So if you get 100, if suppose 100. So among 100 pixels, 40 pixels are with the 0th intensity. Okay. With the 0th intensity. So that's why here, if you may, what is that? Imagine like that. Okay, 40 pixels are with the 0th intensity means that image is the dark image, right? So 6 out of 100, 40 or 0 means the picture looks like a dark image. So you can estimate that one easily. Okay, from this histogram. Okay, and then here, coming to the second method. So here the second method is based on the P of Rk and Rk. P of Rk is nothing but Nk by N. So here in the same way from the image, you just finish the two columns like a gray level, number of pixels Nk, so as in the previous case. And coming to the, so here add the third column, that is nothing but P of Rk. So P of Rk is nothing but Nk by Mn or small n. Mn is here, I am taking small n. Mn means total number of pixels in the image, right? So that's why here, if total number of pixels in the image is 100, so here do the calculation. What is that? 40 by 100. Then fine. What is that? 0.4. 20 by 100 and so on. 3 by 100. 2 by 100. Then you can get the values like this. If you add all these values, you should get the 1 value. Should get the 1. You add all these, you should get 1. So here the maximum value of a P of Rk is 1. Okay. So then here take the graph here. On y-axis, note on P of Rk, and x-axis take the Rk values, right? So then here 0th intensity value is 0.4, like 1 intensity value is 0.2. 2 intensity value is nothing but 0.1 and so on. Like this, you just draw the graph, right? So what is the here? What is the advantage here? You just limit the upper value here. Okay, always to the 1. Okay, so instead of the mn, right? Mn. So here you just limit the upper value to the 1 value. That is the advantage here. So now here. Maximum value plotted will always be 1. That is the advantage. Of course, a great deal of information can be obtained just by looking at histogram. Okay, right. Next one is the types of histograms, right? That means here, by drawing seeing these histograms for the different images, you can easily understand. So this image is which type, right? So here consider this one. What is this here? This is the histogram. So if you observe this one, almost the lines, the discrete lines are closer to this 0, right? So there are no values, right, at this one, right? So that means a large gray levels, right? So here these lines are closer to the 0th intensity. In such a case, that image is nothing but a dark image. What is that? Dark image. If suppose the histogram is like this, that means here almost all the lines are closer to the higher intensity levels, higher gray levels. So in such a case, that image looks like a bright image, right? Now coming to this one, so third one. So here, if you observe particular histograms, if you observe the histogram, particular lines are actually so like a certain band, right? So in between certain band, that particular lines will be appeared, right? So that means those are at any place, right? So not exactly in the zero, I mean low level, low intensity level, or at the higher intensity level. Other than these two values, if you observe the histogram like a some certain band, right? So that means other than this band, we cannot find out the any lines, right? So okay, right? So in such a case, this type of image is said to be low contrast image. What is that? Low contrast image. So here, that coming to the last one, if you observe the histogram of the particular image, if all the lines are particular histogram lines, discrete lines are equally distributed. So not exactly equal. So you can observe like this. So here observe, here are the higher value, here is the higher value, so here is the lower value, but every intensity is involving in this histogram. Am I correct? In such a case, this is said to be high contrast image. High contrast image, we actually need this type of high contrast image. So this high contrast image gives you the what is that full information, and then that looks like a good image. All right. So what is that best image? Okay. So that's such that here, if you observe the particular histogram, you can easily say that what is the nature of the image, right? So okay, here, so that means, see this is the dark image, this is the bright image, this is the low contrast image, this is the equalized image or high contrast image. Every image should be converted, right, from all these modes to this mode, right? This is the aim here, right? How can you enhance the image means, if you have this type of an image, we should convert this image into this form. We should convert this type of image to this form. You can convert this type of image to this form. That means our aim is to get the, what is that? Equalized image. In such a case, that image is said to be enhanced image, a good image, right? Okay, so that is the intention here. After observing the histogram, so by placing the histogram equalization, after getting the equalized image, you can enhance the image, right? It's okay. Now here, the last graph represents the best image. It is a high contrast image. Our aim would be to transform the first three histograms into the fourth type. In other words, we try to increase the dynamic range of the image. It's okay. Now coming to this one example. So histogram of an image, that is a graph of number of pixels versus intensities. And then here the formula is h of rk is equal to nk. And then take an example. This is an image. If you see this one, what is that? So that is a dark image. So you can easily understand that one. So there is a dark image. So that means if you observe the histogram of this image, right? So see here, so low intensity levels are there, here are higher intensity levels, but our histogram is, that means all the lines, discrete lines are placed nearby the zero intensity values. That's why here by seeing this histogram also, you can easily say that the image is belonging to, what is that, the type, what is it, dark image. Now coming to this one, so see this here, observe also how much variation is there. Okay, so right, see this here, this is an image, and if you observe the histogram, it looks like this. That means here what is that, is closer to the higher intensity levels. So here this is nothing but bright image, right? Now coming to the next one, low contrast image. So this is the low contrast image. So if you observe the histogram, so it looks like this. Okay, see this at certain band or certain range of intensities only we have the lines, histogram lines. Other than there are no particular histogram lines observed. So in such a way, if you see the histogram, that image is said to be, what is that, low contrast image. And here you should get the particular variation between the dark image, bright image, and also low contrast image. See this is a low contrast image. Okay, right? So and then observe the variation between dark, bright, low contrast. It's okay. Now see this. This is a high contrast image, and see this variation between all those four, right? Dark, bright, low contrast, high contrast. Which one is better one? So if I give you this 4 images to you, so select one good image means obviously you can select this image. Am I correct? So here this is the very good image, right? So by seeing this one, every detail is there. So there is no particularly what is that missing one, right? So the detail, there is a particular change here. So here also small dots also we will see, right? Okay. So if you see this, and then there is a separation between dark and bright also, right? So okay, see this, right? So if you see this, you can easily say that there is a dull image like that. Okay, right? Washed out image. Okay, it's okay. High contrast image. Suppose that means here this is a good image. Of course, if you observe the histogram, how it would be. See this. So here, and almost all the intensity levels are involving in this particular, what is that, graph, right? Am I correct? That means if for any image, if you get the histogram like this, that image is nothing but good image. Okay, right? This is the high contrast image. So remember here the 4 different types. One is the dark, bright, low contrast, high contrast, and each and every image should be converted into the high contrast image. Okay, so okay. Now coming to the histogram processing. Histogram processing means, what is that here? So here if you observe, if suppose histogram like this, right? So I'm drawing here continuously. It's okay. It's like this. So that has certain particular defect. Okay. So some what is that? That image should be enhanced. How can we enhance that image? We should distribute. We should distribute particular nature, histogram nature like this, uniformly like this. Am I correct? So in such a case, you can enhance the image. So that's why here, if the graph is like this, you should get the graph, or you should convert this graph from this mode to this mode. So in such a case, that is said to be histogram equalization, right? So histogram equalization is one. So here to get the histogram, what is that, distributed uniformly, but it is not in our hand. Based on one formula, so it automatically generates the equalized histogram, right? So one basic formula is there. Based on that, it will happen, right? So but if suppose you may select particular histogram, right? You may draw the histogram like this. Okay, right? That means there is no automation. That means here, according to the user intention, according to the user specifications, so they should. That means the image histogram is changed. Like what is that? So user specification. So in such a case, there is no standard formula. User can develop a formula related to her or his intention. So that's related to that only you can get the uniform distribution in the histogram. That is nothing but histogram matching or specification. So here, observe these two variations here, histogram equalization, histogram matching. Both are used to enhance the image or to get the uniform distribution of the histogram in both cases. But one is the in one method we are using the fixed formula, and in another method we just give the our own formula, okay, desired formula. Okay, so that is the difference between these two, histogram equalization and histogram matching or specification. Okay, so here histogram equalization, so what is the use of this one? That means to improve the contrast of an image, to transform an image in such a way that the transformed image has a nearly uniform distribution of pixel values. So this is the here reason to do the histogram equalization. So, okay, so to transform here, what is it? In this one, we should follow the two conditions here. What is that here? S is nothing but T of R. Of course, you know that R is in between 0 to 1. And here S is equal to T of R. This is the basic formula. In this way, you should transform, okay, the given image. So point operation formula. So here you should satisfy the conditions. What are they? The first one is T of R is a single valued and monotonically increasing in the interval 0 to 1. Okay, so here that means it cannot be the multi-valued, right? So T of R is a single valued, right? And monotonically increasing in the interval, like this graph, right? So in this way, so here the transformation should be like this. So then only you can get the, what is that, histogram equalization. Okay, and then the next one is nothing but, what is that? So here R range is 0 to 1. You know that R range is 0 to 1. Obviously, S range also 0 to 1. So here that means 0 to 255 levels are there in the particular 8-bit image R values. So you cannot, what is that, in the particular S also, in the particular S, that means enhanced image also, the gray levels are in between 0 to 255 levels only. Okay, you could not change that gray levels count. Okay, right? So that is the second condition. What is that? R range is 0 to 1, and of course S range also 0 to 1. Okay, so here 0 to 1 means we are normalized the values. 0 to 255 values are normalized into the 0 to 1. Okay, so in such a way we just consider like this 0 to 1. Okay, so okay, now here say this, here 0 to 1 means here also 0 to 1, and then this is monotonically increasing. It could not be like this. So if it is flat, so suppose if it is flat, for many values of R, you can get the same value of S. So under this case, we cannot get the histogram equalization. Okay, so right, that is the case here. So okay, now coming to the histogram equalization. So here in the continuous level, you have a small derivation. Based on that, you just assign that one to the discrete condition. So here I directly tell you the discrete version case. Okay, so no need here continuous version case. Here. Histogram equalization or linearization transformation function is nothing but Sk is T of Rk, that is equal to, here I am writing the equation, right? So by using this equation, I just equalize the histogram. Okay, L minus 1 into summation PR of Rj. PR of Rj is nothing but Nk by N. Actually, PR of R is Nk by N. Here I am using J symbol, that's why Nj by N. So that means here Sk is nothing but, what is that, modified image, enhanced image, S of x comma y, like that. That is equal to L minus 1 summation Nj by N, where J value from 0 to K. K is nothing but 0 to L minus 1. Okay, so this is the thing here. This is the formula. We should remember this formula. Based on this formula, you should equalize the histogram. Okay, right? So there's an output image is obtained by mapping each pixel with level Rk in the input image into a corresponding pixel with level Sk. Right? So here, So observe this one. If I apply this histogram equalization, this equation, right? So here I can get the image like this. Observe this dark image, dark image. You have seen the histogram also. If I apply histogram equalization, so my new image, enhanced image histogram is like this. Observe this one. Okay, that means here we can get the image like this. Which one is better among these two? This one. Okay, so right now coming to this one, bright image. So observe this one. Okay, right here also, and observe the histogram also. And now see this. Right. So here in this way, you can observe the low contrast image case also. Okay. So that is the histogram equalization. So now coming to the local histogram processing. Local histogram processing means up to now we have observed the global histogram processing. That means for whole image we are applying this transformation equation, histogram equalization equation. Then you can get the what is that equalized histogram, then you can get the high contrast image. But in all applications it is not the correct method. So for some cases we should apply the local histogram processing. That means if the image is decomposed into the several parts, and then you just apply the histogram processing on the subpart of the particular image, right? That is the intention here, local histogram processing. Histogram processing methods discussed are global up to now, in the sense that pixels are modified by a transformation function based on the intensity distribution of an entire image. So there are some cases in which it is necessary to enhance detail over small areas in an image. This procedure is to define a neighborhood and moves its center pixel to the pixel. Okay, that means here at each location, the histogram of the points in the neighborhood is computed, and there is histogram equalization and histogram specification transformation function is obtained. So here that means what is the what is this one means here up to now we have seen the point operation. What is that histogram processing also related to the point operation technique. But now here this local histogram processing is belonging to the neighborhood operation. Why? Because here I am decomposing my image into the several parts, and at each part I am observing the histogram. Based on that histogram, so I should equalize the I should apply the transformation operation, like what is it, L minus 1 summation nj by n. So based on that one, so I just enhance that local part of the particular image. That means it is almost, this operation is not like a point operation. This operation is belonging to the neighborhood operation. So that is the thing here. So that means histogram processing global one is related to point operation. Local histogram processing is related to the spatial operation or neighborhood operation. So remember this point also here. And then at each location, the histogram of the points in the neighborhood is computed, and either a histogram equalization or histogram specification transformation function is obtained. Map the intensity of the pixel centered in the neighborhood, and center of the neighborhood region is then moved to an adjacent pixel location. Okay, right? So now here this approach has obvious advantages over repeatedly computing the histogram of all pixels in the neighborhood region. Each time the region is moved one pixel location. Another approach used sometimes to reduce the computations is to utilize non-overlapping regions, but this method usually produces an undesirably blocky effect. It's okay. See this example, we will understand that one. So here observe this one. So can you identify any objects in the dark or black color? See here. So in the first look, we could not observe anything. So there is nothing but one gray color, and there is nothing but gray. So observe here. What is that? Keenly here. So what is that? So some objects are there in this one. Okay, right? So if I apply here global histogram equalization, I can get the image like this. See this, right? So here that means here that the method is not useful here in this case. Am I correct? So here my intention is here only, this part only. So not here. But after applying global histogram, right? So equalization, so I can get the image like this. But this is not the one our desired one. So in such a case here, use the local histogram equalization. Here take the neighborhood size 3 by 3. That means here split this image like 3 by 3 parts, 3 by 3 parts of the so many images, and take 3 by 3 what is that size of an image, and then there apply the histogram equalization, right? So here for each 3 by 3 size, right? 3 by 3, just you find the histogram and then apply the histogram transformation. So then you can get the equalized image. So in such a way, after applying this local histogram equalization, you can get the image like this. Observe this one. Okay, right? So you can observe the particular images, right? So okay, some noises there, and some by applying after some techniques, you can nullify this noise also. Okay, right? So here our main intention is to enhance the image. What is that? To see the objects here. Okay, see this. Okay, so here and then the variation between the global histogram and the local histogram. Observe this one. Okay, so this is the one here. What is that? Difference between local and global. Okay, up to now we have completed what is that? Histogram and histogram equations. How can you represent in two methods? You can draw the histogram. The first one is based on H of RK versus RK. Another one is P of RK versus RK. And then based on the histogram, how can you identify the image, what is the different types of an images, and then based on that histograms, so how can you enhance the particular image, and what is the histogram equalization, and what is the histogram specification, and under the histogram equalization, so what is the transformation operation, or the what is the relation between S and R, and then here what is the global histogram processing, and what is the local histogram processing. Okay, then any doubts here? One minute, I am taking attendance. Two is absent. It's two absent. Until 9 also absent. $55 absent.